Alright guys, so we're going to be looking at the parallel line development, right? We're going to be looking at a truncated prism and we're going to open it out like a stretch out. This is what we call a stretch out, or it's also called a parallel line development, right? So this is what we're going to be looking at today. Okay, so the first thing we want to do is we want to label our drawings. We're going to be using something called Alphanumeric labels. And what that is, we're going to put numbers at the bottom, letters on the top. I'm going to start with 1, 2, 3. I'm going to place my edge that we can't see here. I'm going to use hidden lines, but remember, we don't ever use hidden lines on an isometric. This is so you can identify that particular point we can't see. So this is 4. Now we're going to go in with the letters. So we'll have A over 1, B over 2, C over 3, and D over 4. I'm going to go in with the letters that I've put at the base and place it on my orthographic projection. So on my right side surface, I have 1 at the bottom right. So I'm going to go 1, 2. The numbers that overlap or behind these particular corners or edges, we're going to put them on the inside of the drawing. So what's closest to us is in front. What is furthest is going to be on the inside. We'll do it on our front view as well. So my front, the 2 is on this side, then 3. 4 is behind 3, so it goes on the inside. 1 is behind 2, so it goes on the inside. We'll do it on our top view as well. Now the numbers are furthest from the top because it's at the base, so it's going to be all inside. 1 will start at this corner, 2, 3, 4. And all I'm doing is relating it to what I have in my isometric. We're going to go in with our letters now on the right side view. So A is over 1, B, C, D. We'll do it again on our front view. B and C is in front, so we'll go B and we'll go C. We also see that C is the same height and B is also here as well. So A is behind B, so it goes on the inside, and D is behind C, so it goes on the inside. And all of our letters on the top view is going to be on the outside. So we have A is outside 1, B, C, D. So now we've done our alphanumeric labels. The next thing we're going to look at is our auxiliary view by rotation. We've looked at auxiliary view by projection, so now we're going to look at auxiliary views by rotation. Now, one of the easiest ways to do this is to take a sheet of paper and you're going to make a mark of the length of your incline, and I'm going to take this and I'm going to rotate it. So I'm going to keep this at the top here and I'm going to rotate it to my horizontal. The horizontal is where the top of the object touches. So now this is my mark, right? I've just rotated it. Another way we can look at this is to use a compass. So again, I'm going to put my compass here, right? If we were doing it using tools, right now the first way I showed you is using a sketch. This way is a tool, right? I'll take the distance, make a little mark, and then I'm going to rotate, right? So my first one was a little off. Let's just double check that. Yeah, it's probably shifted, right? So now this is the actual mark. And since it's a sketch, you know, using the initial mark we had, that's fine. Now we have this edge. We're going to project that up to the top view. Okay, I'm going to use my paper just to give me a guide to go straight up. And then I'm going to use the characteristic of a hidden line. Now it's not a hidden detail, but it is a way we are identifying our auxiliary view. Okay, so we're identifying our auxiliary view. It's now from here to here is going to be our full width of that inclined surface. And we're going to label it with prime. So we use our auxiliary view to add the additional view to give us the true surface of our incline in our orthographic projection. Now we'll go into the development. So my first thing is I'm going to extend the base. So I'm projecting a line from the base and I'm going to go straight across. I'm not sure where it's going to end yet, so I'm just going to go straight across. Okay? I'm also going to do it at the top. And I'm going to go straight across. Now this first line that we drew, this line is going to be called our stretch out line. Okay? I'm going to start my development the same amount of units I've used to separate my views. Normally I use 2, but this one I use 3 just so I can have space between my labels. So I've started my stretch out here. I'm going to start with my numbers at the base. So I'm going to start with 1. And when I have 1, I'm now going to look at the units that I have from 1 to 2. So we have 1, 2, 3, 4 units. I'm going to count 1, 2, 3, 4. This edge is going to now be 2. I'm going to extend a line here. I'll do the same thing for 3. So I'm going to count 1, 2, 3, 4. And we're going to have 3. We'll do the same thing again for 4. So we have 4 units as 4 as well. Right, you're going to look at it. Where is it on your orthographic projection? We're going to take that measurement. 1, 2, 3, 4. So we have 4, and we're going to pull a line. Now, within this, we can end here, but if we look at our lateral surfaces, and that's what these are called, lateral surfaces, we have 1, 2, 3. But what wraps around our surface is going to be 1, 2, 3, 4 sides. So we then need to end with the start number. So I'm going to go back to 1. 1, 2, 3, 4. That's going to be 1, and I'm going to draw a line. Right, so good note, whatever number or letter we start with, it's going to end with that as well. This is going to be the perimeter of my object. This is how wide it's going to be. That's why we have the stretch out line. So I'm going to erase this piece now. We don't need that. So I'm going to extend this particular feature as well over to my development. And now we're going to go in with the letters. So I'll start with A, which is also here. A is over 1, so A is going to be right here. Then we look at B. B is on the same line, and it's over 2. So we're going to go B. On the development, we do not put any of the numbers or letters on the inside because it's laid out flat. It's on one plane. Now I'll look at C. If I look at C here, I've projected it across. It's going to be the height. It's over 3. So we have C. D is over 4. And then, as we said before, whatever we started with, that's what we're going to end with. So it's going to be 4. Okay? Now we can connect our lines. So I'm going to define my edges for what I have so far. Okay? But, and remember what I said before, this is called our lateral surface. Okay? All of our surfaces. So right now we have 1, 2, 3, 4. But if we look at our isometric, it's made up of 1, 2, 3, 4, 5, 6. So a box is always made up of 6 sides. So we need our incline and we need our base, or the top and the base. Our base is going to be 4 units all around. So I'm going to choose the surface that has the most material, or is the longest, right? So I'm going to place it at the bottom here. It has a little more structure to hold this extra material. So I'm going to shift my 3 around. And I'm going to extend here, all right? Now, if the stretch out line before it shares the same, is going to be in contact with this, right? So if we look at this, between 2 and 3, the base of it also touches 2 and 3's base as well. So another way we can look at this is we can place this here, and we can also make a mark from 2, and it gives you about the same distance, come out a bit, right, for it. And we can do it on the other side as well, or we can also go across. So this can give us our same height. I'm going to define this. And then we're going to look at the incline at the top, right? We already have the true length of it here, and we can also put it here. So it can go in either direction. It can go here, or it can go here. If we look at our example that we have here, this is what we're going to have if I placed it here. But I don't want it to be too close to my isometric. So I'm going to do it on the opposite side. We just have this piece. It's going to be here. So it doesn't matter where you start certain things, right? So I'm going to do it here. And again, D and 4, right? C and D is going to be matching each other, which means it's the same distance or the same measurement or dimension. So I'm going to make a mark again. Wait, first, I need to project perpendicularly from the inclined surface. So I'm going to go here. I can go in this way. We cannot count 4 units this way because it's going to be too long. But I can go in and make a mark and carry it over. Right? I can make a mark like this and carry it over, and then I can connect like that. If we were going with tools as well, we can go this way as well. This is going to be the same distance as well. We cannot do it from here because these actually do not connect. Okay, it's really A and B is going to connect to this portion here. Wait, why do I have 4 here? It should not be 4. It should be A. So we're just going to connect that based off of my initial guides that I put down. All right, so I can go in and define my line. And now we have the full component. It's just this edge is on the outer edge here. Now with this, we have fold lines, right? So these where they bend is called a fold line. We have to represent those within our drawing, which is represented using the characteristics of a hidden line. So wherever I have a fold, I'm going to create short dashed lines. Okay, same thing on this side. We also have it at the base. And this side as well. All right. And that is it for our development. We've looked at alphanumeric labeling, where we have the numbers at the bottom, letters at the top. We've looked at auxiliary by rotation, where it gives us an additional view for the true shape of our inclined surface. And we also looked at the development, which gives us, we have our stretch out line. We have each part of these are called lateral surfaces. Okay, but the only other thing that we have missing, as I'm looking at it, we also need to include the rest of our labels. So here we have A, right? If we look at it, C is on the shorter end, and if we look at it, C is supposed to connect to C. This part is going to connect here on the other side. Sorry, B, not A. And then the same thing goes here again. So we have 4, 3, 2, 1. All right, guys, and that is our parallel line development. I hope this helps.